Hi everybody, this is your friend, teacher, K, my physics teacher, and I want to walk you through the world of physics. Now, if we say physics is all over around you, how would you feel, or what do you think? Take for instance, you wake up in the morning, you walk out, the sun is shining, you have rays hitting your head, trying to keep warm, right? That is physics, thermal aspect of it. Now, as you take steps, you are converting energy, right? In a form of mechanical energy, kinetic energy, and all those kind of stuff coming into play. However, if we look at things all around us, everything expresses the idea of something pulling or supporting it. Now, physics is the world, and the world is physics. The world will not exist without physics at play. However, as a freshman, having no idea about what physics is, and probably that is my goal, I just want to walk you through what to expect. Physics is fun, and therefore you need not be afraid. Yes, people have said so many things, but hey, to me, and based on what we are going to be walking through, you come to understand that, hey, physics is nothing but rather is one of the easiest subjects. Yes, people have their challenges, but hey, we'll try our best to make it easy and then fun for you. So why don't you join me? So first and foremost, we look at the introductory aspect of physics. Now, physics is a branch of science that deals with the study of energy and matter, right? And how they are related to each other. And so, from your knowledge in basic science, matter is anything that has mass and occupies space. But then, if it's occupying space, then it also holds something within, which is a form which keeps it in that state that in which it is in. And so, if a solid lies on the ground, it has some energy to support it to lie down. If a solid is moving from one point to another, it has some form of energy causing it to move. Now, I don't want to get into the intriguing part of it, but for now, for introductory physics, we are going to look at concepts like what we call physical quantities. Physical quantities. Now, what is a quantity? What is a quantity? Now, a quantity is anything, one, that can be measured either by using a measuring instrument or can be calculated using the idea of what we call dimensions. From basic mathematics, solids, liquids, a solid has length, breadth, and then height, right? And so liquids do not have, but liquids normally take the shape of their container. And therefore, if you want to measure the area or the volume, we don't have an area of a solid, but rather we have the volume of a liquid. Sorry about that. Now, a quantity can be measured. They can be measured or calculated at the lab. Now, we have two main physical quantities. Now, when you read other books, you come across a couple of them. In some references, we have what we call the base quantities. We have the derived quantity. We have the derived scalar quantity. And then we have that of a vector quantity. Now, all these are interrelated. And as we move along, you see how they are connected, right? Now, when we talk of a base quantity is any quantity which cannot be derived or not be deduced from any other thing. More or less, it is the foundation. It is the first step to getting the others. You can think of a base quantity as a cell, since we said cells are the basic units of life. And so a cell is likened to that of a base quantity. I hope you get it. Now, when we put two base quantities together, we have what we call a derived quantity. Now, an example of a base quantity is time. Time is a base quantity. Length is a base quantity. But when I put a length and a length together, when I put two lengths together, I have what we call an area. When I multiply them, I have an area. And so area becomes a derived quantity. Another one, length times length times length. I have three things. And therefore we have what we call a volume, right? And so volume becomes a derived quantity. However, all these quantities that we are talking of, the next point is a scalar. Now, a scalar quantity has magnitude, but take note, it has no direction. Take, for instance, I ask you to climb the ladder. Now, the first thing that comes to mind, what part or where am I heading? Or I ask you to take a walk. You cover a certain distance, let's say 10 meters. 10 meters what? I don't know where you went, what direction that you took. And therefore, any figure that you recall, any figure that we measure or we note down becomes a scalar quantity. And so, for instance, if I write 10 meters, just 10 meters alone gives me an idea of a scalar quantity. It has the magnitude, but there's no direction to it. However, for us to make more meaning or make whatever we are measuring more impactful, then we add the direction to it. And that gives us what we call the vector quantity. I hope you are doing great. Right. And so a vector quantity has magnitude, that is the measure, and then has direction. And so initially I asked you to take a walk. And then you walked 10 meters. My follow-up question is, what direction did you take? Okay, I walked 10 meters to the left or 10 meters to the right. 10 meters east, 10 meters south or west. I hope you're getting it. And so the moment I add direction to it, then it changes from being a scalar to a vector quantity. I hope you're getting the point. See, it's as easy as I'm saying it. There is no ambiguity in here. I hope you get it. And so a scalar quantity has magnitude but no direction. And a typical example of a scalar quantity is distance, length, right? Time is a scalar quantity. Don't forget, we said time is a base quantity. But time has magnitude but no direction. I hope you get it. You can imagine time looking at your clock and somebody did your digital clock or whatsoever. Time has magnitude but no direction. But then if I add a direction to it, a typical example, distance is a scalar quantity, but when I talk of speed, velocity, now all these terms, all these words that I'm mentioning, as we move along, I will explain each and every one of them for you to understand it better. All right? And so velocity is a vector quantity. Why? It is giving you the exact direction in which the measure is expressed in. I hope you get it. And so basically, when we talk of physical quantities, right, as I said, these are quantities that helps us to understand, really appreciate the concept of physics. Okay? Because that is the basics. Everything has something to identify it. Okay? Just as when you were born, you were given a name. So as soon as that name is mentioned, you know that hey, that is me. But if there is no name, then somebody calls me, hey, you are at liberty to respond or not. Right? But then So physical quantities brings meaning, understanding to whatever thing that we are trying to describe. Okay? And then we said that a quantity is anything that can be measured at the lab or can be calculated for using the dimensions of that particular quantity. Now, we also said that technically we have two main quantities, but then to make it simple and break it down, we have four. Now, the four, in a broader sense, we have the base quantities, we have the derived quantities, and we have scalar quantities and the vector quantity. All right? Now, base quantities forms the basis of all the other ones. It's the stepping stone, the first step. They are quantities which cannot be deduced or derived from any other quantity at all. And then a derived quantity is a quantity that is obtained as a result of putting together two base quantities, two or more. Now, the third quantity which we spoke of is the scalar quantity. And we said that a scalar quantity is any quantity that has magnitude but has no direction. And a typical or classical example is distance. Distance is a scalar quantity. Speed is a scalar quantity, right? Mass is a scalar quantity. Length is a scalar quantity. They all have magnitude, but they don't have direction. Now they are to a step forward. The last quantity is the vector quantity. And we said that vector quantity brings meaning, additional information to whatever we want to say. So vector quantities have both magnitude and direction. And so if I talk of 10 meters, which is distance, the moment I add direction to it, 10 meters north, then it changes from being a scalar quantity to a vector quantity. Are we good? Velocity is part, displacement is part, all right? Even current has magnitude and direction. Voltage has magnitude and direction. Okay? And so, to sum it all up, physical quantities form the basics or form the starting point of your journey in physics. I hope you understood all that I said, and follow up for the next video as we move along. Have a great day. Bye.